Hello grade 8. Today we're going to continue the first chapter that we discussed last time, which is oxidation reduction reactions, and we're going today to move to the first part of the second part, which is redox reactions number 1. The objectives of our session today is to define a redox reaction and to apply the oxidation number method for identifying a redox reaction. Let's start. What is a redox reaction? Redox reaction or oxidation reduction reaction is a reaction where there is a transfer of electrons between the reactants. So we have a transfer of electrons between the reactants. Examples of redox reactions: we have reactions occurring in a car battery that we're going to discuss later in the next lessons. We have combustion of fuel and iron rusting. All of these, they are redox reactions. They are examples of redox reactions. Okay, type. The name of redox reaction came from oxidation reduction. So we have two phenomena that occur during the redox reaction. We have oxidation and reduction. What is oxidation? Oxidation is a process by which a chemical species loses one or more electrons. So when a chemical species loses one or more electron, it undergoes what? Oxidation. For example, we have here Na is losing one electron to become Na+. So Na undergo what? Oxidation. Yani Na, sodium ion, it undergoes oxidation to become Na+. So it loses one electron. So the process of loss of electrons is called oxidation. The second one is called the reduction, the second reaction. The second reaction, which is the second one, which is called the reduction. Reduction is the process by which a chemical species gains one or more electrons. So when a chemical species gains an electron, it can gain one or more electron. So it's called reduction. For example, here Cl is gaining one electron to become Cl-. So Cl here undergoes reduction because it gained one electron. Okay, so here we have an acronym for better understanding and for better memorizing the oxidation and reduction definitions. We have here Leo says Ger. Leo, the lion yani. Leo, L is for loss, E is for electrons, and O is for oxidation. So Leo is loss of electrons is oxidation, and here we have Ger. G is for gain, E is for electron, and R is for reduction. So gain of electron is reduction. Now, this was the first objective, that to define a redox reaction. So redox reaction is reactions where we have a transfer of electrons between reactants, and oxidation is the process where a chemical species lose electrons, and reduction where a chemical species gain electron. Type. And so the second objective of our session is to apply the method of oxidation number to identify redox reactions. But before going to this method, let's remember the oxidation number rules. The first one, oxidation number of elements is equal to 0. Oxidation number of monoatomic ions is equal to their charge. In compounds, we have the oxidation number of Na, Li, and K is +1. Oxidation number of Mg, Be, Ca is +2. Note that because Na, Li, and K are in column 1 or group 1, we have Mg, Be, Ca are in group 2. That's why their oxidation number is equal to +2. Oxidation number of Al is in group 3, so it's +3. Oxidation number of F is -1. Oxidation number of oxygen O is -2. In any compound except if it is found in where? In H2O2, which is hydrogen peroxide. Its oxidation number is equal to -1. And finally, we have the oxidation number of H when bonded to a non-metal is +1. We have the summation of elements in a compound is equal to 0. The summation of oxidation number of elements in a compound is equal to 0, and the oxidation number, the summation of oxidation number of elements in a polyatomic ion is equal to its charge. So how to identify a redox reaction by applying the oxidation number method? We have this reaction that says Fe plus Cu2 plus gives Fe2 plus Cu. This is a equation, a reaction between Fe and Cu2 plus, يعني iron and copper ion. Okay, we're going to see what will happen and what we will do. First of all, we should find the oxidation number of all elements found in this reaction. So the first one, what do we have the first one in the reactants? We have Fe. So what's the oxidation number of Fe? It is in its elemental form, يعني it's equal to 0. So we make a line, we draw a line, and we write oxidation number, which is 0. Okay, right. We have the second reactant, which is Cu2 plus. I'm going to change the color to green, for example. Cu2 plus is Cu is a monoatomic ion, so its oxidation number is equal to its charge. So the charge is +2. Why? Because the oxidation number is +2 because the charge is 2 plus. Type, we have the products now. We have Fe. Type Fe, so we're going to change the color to red. Fe, it has what? It is in its monoatomic state, يعني it's ionic state, اللي هي شو Fe2 plus. Type Fe2 plus, what's the oxidation number of this one? It should be +2 لأنه الcharge is 2 plus. Bravo. Type. Now we have Cu. Type Cu. What's the state of Cu? It's in its elemental form. So its oxidation number is what? Is 0. So we draw a line like this and write 0. Type. What we should know, what we should do now is we have to follow the oxidation number of each element from the reactants, يعني from the reactants before the arrow to the products after the arrow. Okay, let's start with Fe. I'm going to return to the red color. Fe, it was, or let me change the red, purple, let's say. Okay, we have Fe to Fe2 plus. Type Fe was 0 in the reactants, now it's +2. So the oxidation number of Fe decreased or increased? Of course it increased from 0 to +2. So oxidation number, I'm going to write it, oxidation number of Fe what? Increased. Type, I'm going to choose another color now to look on the Cu, the blue. Okay, we have the Cu, it was Cu2 plus and now it's Cu. Type, the Cu2 plus has an oxidation number of +2 and now it's Cu in the product. So the oxidation number decreased. So I'm going to write it. Oxidation number of Cu decreased. Did you understand? So it's very easy. It's very simple. You just have to write the oxidation number of each element found in the reaction, and you follow it from the product to from the reactant to the products. Okay, so as you can see here, Fe Fe oxidation number of Fe increased from 0 to +2, and copper ion يعني Cu2 plus decreased from +2 to 0. Type. Okay, so after this you should know two important rules, that when the oxidation, I'm going to change, let me see this, the black one. Type. Oxidation number of when the oxidation number increased, this is called oxidation. I'm going to write it like this, oxy. Okay, so oxidation. When the oxidation number increases, the element undergoes oxidation. يعني ال Fe, it is Fe2 plus, so it lost 2 electrons. يعني it's what? Oxidation. Type. I'm going to use another color for this. We have the darker blue. Type. When the oxidation number decreases, this is called what? Reduction. Okay, so we have the oxidation. When an element undergoes oxidation, we know that its oxidation number has increased, and when it undergoes reduction, its oxidation number decreased. So we have the oxidation number of Fe increased from 0 to +2, so Fe undergoes oxidation, and the oxidation number of Cu decreased from +2 to 0, so Cu undergoes reduction. And since there is a variation, this is important, you should write when a question says to identify if the reaction is a redox or not, you have to write these three things. Again, of course, after calculating the oxidation number of each element found. Okay, so since there is a variation in the oxidation number, so there is oxidation and reduction. Okay, so this reaction is called a redox reaction, or this is a redox reaction. Okay, it's very easy. So you should write the oxidation number. لأنه ال Fe increased from 0 to +2, so it's oxidation. Well, Cu decreased from +2 to 0, so it's reduction, and we have oxidation and reduction due to the variation of oxidation number, so it is a redox reaction. Okay? So the important rules that you should know, that if the oxidation number of an element increases, the element undergoes oxidation. If the oxidation number of an element decreases, the element undergoes reduction. And because we have a variation of oxidation number, this is a redox reaction. And note that we should have inside the reaction oxidation and reduction. If we have only oxidation, it's not called a redox reaction, because redox reaction we have oxidation and reduction. Okay, type. Here we have another example. We have to determine if this reaction is a redox or not. We have many examples coming, but this is the first example. Type. H plus OH minus equals H2O. Type. نحن what do we have here? We have, what are the elements found? H and O. Type. Let's start by the H. I'm going to use the red one now. Type. Red. H plus. What's the oxidation number? It's equal to, it's a charge, it's a monoatomic ion, so it's a +1. Type. Here we have OH. Type OH. I don't want to look at O now. We're going to look only at H. So H, if it is present in a compound, it's what? It has also +1. Type. Here in the products we have H2O. Type. H here, it is present in a compound, so its oxidation number is +1. Okay, so the H here is +1, and here it's +1, and here is +1. Let's move to the O, the green color. Type O. What's the oxidation number of O in any compound except H2O2? It's -2. Bravo. Type. What's the oxidation number of O here, كمان? No, it's in a compound and it's not found in H2O2. This is H2O. So 2 minus 2. Type. So let's follow the H. We said we have to follow the H in all forms, in all from the reactants to the products. Type. I'm going to draw a horizontal line to follow it. It's +1, +1, and +1. We don't have any change, so it remains constant. Type. constant. هي oxidation number constant. Type. -2. O. We have in the reactants it was -2, and in the product it's also -2, so it's constant. Okay, did you understand? It's very easy. Again, I'm going to tell you, you have to write the oxidation number of each element found and follow each element from the reactants to the product. So in this example, we have the oxidation number of H remained constant, the oxidation number of O remained constant, so there was no oxidation nor reduction. Therefore, this reaction is not a redox reaction. Okay, we have more examples. We're going to discuss them next time. So stay tuned, and inshallah, if you have any questions, I will be ready to answer you. Goodbye.